for the last week, we had one student who is Ningye, who answered all these questions correctly. Oh, Ningye is here. Can you unmute yourself and introduce yourself?
My name is Ninyi Shi. I'm in Jam Robinson, 6th grade. My favorite subject is geometry.
Oh, you like geometry. Okay, good. So well, today there's a geometry problem. So shall I give that problem to you?
Okay.
All right, so get prepared, okay? So this problem set is probably the second hardest one among the ones I have signed so far. This is just slightly easier than the ones from previous week. So we only had one student who is Ningye, who answered all these three questions correctly. Okay, so this is as I said, this is a tough problem set. So congratulations, Ningye. Let's go over them, right? We'll start from the first one. Since today we don't have that many students, I will do this. I will let you unmute yourself and announce your name if you want to talk about this problem. But I will reserve the third one to Ningye, okay? So the first problem is 1 divided by A plus 1 divided by B equals 1 divided by 18. And set A is greater than or equal to B. And I'm asking how many AB are there? How many of these? Okay, so who want to talk about this one? Just unmute yourself and announce your name. Any volunteer? Oh, nobody? Well, we have 5 students who had this question answered correctly. The answer is 8, by the way. The answer is 8. If this helps you decide if you want to talk about it or not. Anyone want to talk about this one? This problem? Okay, if nobody want to talk about it, then I'll explain to you my way of doing this. Okay. So this is asking for how many pairs of A and B's. So one thing I need, I want to look at is, look, 1 divided by A, 1 over A plus 1 over B is 1 over 18. So what's the range of these numbers? Okay, it says A is greater than B. So there's one example I can think of easily. If A equals B, then this will be 1 over 36 plus 1 over 36 equals 1 over 18, right? So we know there's at least 36 would work. Okay. And beyond this, anything else we can do about it? So this will be the A. So this one of them is A. The other one is B. It said A is greater than B, so that means 1 over A must be less than or equal to 1 over B. Again, these are whole numbers. Okay, these are positive integers. So 1 over A must be less than or equal to 1 over B. In other words, if you look at this one, the B, the largest number B can have is 36. Okay, B should be less than or equal to 36. Okay. Think about it. If B is greater than 36, then 1 over B will be less than 1 over 36, right? So that means 1 over A will be greater than 1 over 36. Then A will be less than 36. So that contradicts A greater than or equal to B, right? So the biggest number B can have is 36. So up to here, I fixed the upper bound of B, okay? And then I keep going, I keep moving. Like, think about it, what's the smallest value B can have? The smallest value, okay? So this is the max. The largest number B can have is 36. What's the smallest one? So if it's 1 over A plus 1 over B is 1 over 18. If A is a big number, so that means 1 over A will be close to 0, right? So if A is close to 0, then B should be close to 18, right? B should be close to 18. But B should be bigger than 18 because it's adding a positive number equals 1/18. So B should be bigger than 18, right? What is the smallest number B can take if it's greater than 18? Well, easy, right? 19. The next one is 19. And let's see if this works. 1/A plus 1/19 is 1/18. Then what is A? Can we find a whole number for A? Well, I think so. So 1/A will equal to 1/18 minus 1/19 equal to 18 times 19, 19 minus 18, which is 1. So it's 1/18 times 19. I won't calculate this number, but I know this is a whole number, right? So B is something, B is greater than or equal to 19, less than or equal to 36, okay? So this will be, like the first steps. So I know the range of B. And this is about 18 numbers, but not all of them would work. Okay, let's keep going. Back to here, 1/A plus 1/B equals 1/18. And we know B is less than or equal to 36, greater than or equal to 19, sorry, 19. So the smallest one is 19, the biggest one is 36. Okay. So let's keep working on B. So this is saying 1/B is 1/18 minus 1/8. Right? This is 18 times A minus 18, right? A minus 18 over 18 times A. So this is 1/B. And B is, remember, B is a whole number. B is a whole number. Okay, so we need to figure out, hold on, let me, oh, okay, so we can do it this way. So then that means if we multiply B here, multiply 18A here, so this will be 18A equals B times A minus 18, okay. And B is something from 19 to 36, okay. So we can start looking, what kind of number will work, right? So if in this case, we can just do an enumeration. So from B, from 19, we already know 19 will work. Does 20 work? Will 20 work? So if B is 20, 20 times something equal to 18 times something, right? 18 times 8. So 20, the factors of 20 is 4, well, 2, 2, 5. And here is 18. 18 has a 2. So that means A have to have what? So a 2 and a 5. A has to have a 2 and a 5, right? So in this case, we can find, okay, so B is 20. So what number can we have for A? So can we A do, if B is 20, one way to do this is 1/A plus 1/20 equals 1/18. If we do enumeration, so this is, I should dissect here. So if we do enumeration, then 1/A is 1/18 minus 1/20. This is 20 minus 18 divided by 18 times 20. Okay, look at these factors. And by the way, so 20 is the B. 20 is the B. So if this number, I should get rid of this. This is not a good thought. This is 2. If the denominator has factor of 2, then that means this will be a whole number. So this will be 1/180. Okay, in this case, 20 will work. So B can be 20. B is 19 will work. 20 will work. If B is 21, on this side of the equation, that will be 21 minus 18 divided by 21 times 18. Right, so this is 3. So it is a divisor of the denominator. So 21 will work too. Okay, 22, go, come here. 22 minus 18 divided by 22 times 18. This will work too, because this is 4. And 22 has a 2, 18 has a 2. So 22 will work as well. 23 won't work. 23 minus 18 is 5. 23 times 18 doesn't work. So 5, this won't work. 23 won't work. Okay, keep going. 24 minus 18 is 6, so that will work. 25 minus 18 is 7, is a prime number, it doesn't work. 26 minus 18 is 8. Okay, 8 divided by 26 times 18. There's not enough 2s. There's 2 to the third power. There's 1, 2. There's 1, 2. Doesn't work. 27 minus 18 is 9. That will work. 28 minus 18 is 10. Doesn't work. 29 minus 18 is 11. Doesn't work. What? Keep going. 30 minus 18 is 12. So 12 divided by 30 times 18. This works. 31 doesn't work. This is 13. 32 is 14. Doesn't work. 33 minus 18 is 15. Doesn't work. 34 minus 18 is 16. 16 divided by 18 times 34 doesn't work. 35 minus 18 is 17. Doesn't work. 36 works. So how many? 1, 2, 3, 4, 5, 6, 7, 8. In total, 8 of them will work. So the answer is 8. Okay. So for this specific problem, so once we find a range of B, we can dive into this 1 divided by A equals 1 over 18 minus 1 over B, and this is 18B. This is B minus 18. All we need is to make sure the B, when we do the B minus 18, it will be a small number, We want to make sure the denominator has factors have these small number as a factor. So that's it. Okay. So this needs some, when you work on this, you need to find a range, and then you need to make sure B minus 18 is a factor of the denominator, 18B. Okay. Any other questions? Any other solutions? So this is a tough problem. Okay. So it's not easy. You can't just use a smart formula to calculate it directly. But once you get here, you can count them quickly. Kyle, you have a comment? Go ahead, Kyle.
I guess I have another solution.
Okay, go ahead.
So 1 over 8 plus 1 over B equals B over 1 over AB plus A over 1 over
A plus 1 over B equals B plus A over AB. Okay.
Mm-hmm. That equals 1 over 18.
1 over 18.
So,
okay.
So multiply each side by 18.
Okay, multiply each side by 18. 18 times A plus B equal to AB. Okay.
Then multiply each side by, divide each side by 18. No, that's all. So, and then 18 times A plus B equals 100 AB, and then AB minus 18 times 8 plus B equals 0.
Say it again. 18 times what?
AB minus 18 times A plus B
equal to 0.
Equals
okay.
0. And then you can say that AB minus 18A minus 18B plus 18 squared equals 18 squared.
AB minus 18A minus 18B plus 18 square equals 18 square, okay?
That means that A minus 18 times B minus 18 equals AB minus 18. Wait.
Okay. A minus 18 times B minus 18 equals 18 squared. Oh, okay, good. Keep going.
So now I guess you're trying to find numbers that can apply to A minus 18 times B minus 18 equals 18 squared.
Okay. So basically you're trying to factorize 18 squared, right?
Mm-hmm.
Okay.
18 squared equals 3 times 3 times 3 times 3 to the fourth power
Times 2
times
to the
2.
second.
Mm-hmm. So it's 4 plus 1 times 2 plus 1 plus 1 divided by 2 times 2 equals 16. 16 minus 1 plus 1 divided by 2 equals 8.
Slow down, please. Slow down, please.
4
So
plus
4 plus
1
1
times 2
plus
plus 1.
1. So this is how many factors 18 square had, right?
Mm-hmm.
So this is 5 times 3 is 15, okay?
Mm-hmm. Then 15 plus 1 divided by 2 times 2 equals 16.
15, why do you do 15 plus 1?
Well, it's some kind of run of calculations I did. I don't really know how to explain it.
I think maybe, I don't know why you do 15 plus 1 here. But up to here, I think it's, from here on, it's straightforward. Basically, you try to find two numbers multiplied together equal to 18 squared.
Mm-hmm.
And then there's a constraint. You have to have a greater than or equal to b, right? So one way is to make a and b both 36, right? And then you start looking, see, factorize 18 squared and find the factors. So this is, one track to pursue, right? Good. This is smart. Thank you. This is a great solution. I didn't think about this one. All right. Let's move on to the next question. Who want to talk about the next one?
I can.
Who's that?
Raga.
Okay, go ahead.
So first, I wrote the cube root of 2 plus root of 5 plus cube root of 2 minus root of 5 equals x.
You make it equal to x.
Yeah.
Okay.
And then I cubed both sides.
You cube both sides, okay?
Mm-hmm.
Cube both sides.
And then I got 2 plus root of 5.
2 plus square root of 5.
Plus cube root of 2 plus root of 5 whole squared times cube root of 2 minus root of 5.
Okay, so let me write this down. 2 plus square root of 5 squared times 2 minus square root of 5 plus 3 times cube root 2 plus square root of 5 times cube root 2 minus square root of 5 square plus 2 minus square root of 5, correct?
Yeah.
Okay.
And then I combined the 2 plus root of 5 and 2 minus root of 5 to get 4.
Okay, so
With the rest of the
cancel all
expression.
this, okay?
Yeah. And then I took out the 3 from the middle expression.
Mm-hmm. And then?
And then I did cube root of 9 plus 4 root of 5 times 2
Where's
minus
9?
root of.
Why is there a 9?
Because the square goes inside of the expression, inside of the cube root.
Okay. Oh, you squared the inside 2 plus square root of 5?
Yeah.
Is there an easier way to do this? Do you have to put a square?
Oh, yeah. You can take out the 2 plus root of 5 times 2 minus root of 5.
All right. So 2 plus square root of 5 cube root times 2 minus square root of 5 cube root times. So this is what property?
The distributive property.
Correct. Plus, that's right. And then?
Yeah. And then you know that cube root of 2 plus root of 5 plus cube root of 2 minus root of 5 is x.
So this is x, okay?
Yeah.
Okay.
And then you know that the cube root of 2 plus root of 5 times the cube root of 2 minus root of 5 is -1.
-1, okay. And times 3,
Yeah.
right?
And then that is equal to 4 minus 3x.
Equals 4 minus 3x.
And this is all equal to x cubed.
This is equal to x cubed. So now we have x cubed equals 4 minus 3x. Okay, next.
And then you bring every term to the left.
Okay, x cubed plus 3x minus 4 equal to 0. Okay.
And then you can factor it and get x equals 1 or -4.
Oh, you factor it. How did you factor this one? How
So,
can you, by the way, so I said you have a solution. So let's say x equal to 1, that will work, apparently. Okay, that will work. The other one is what? X equal to -4?
Yeah, that won't work because the number has to be positive.
That won't work. So that's not how you factor it, right? So up to here, what do you do up to here?
Just guess.
So look at this function, right? So this function is not easy to solve. Okay, this is not an easy function. But just look at it, right? So this is x cubed, this 3x. The coefficient to this one is 1, coefficient to this one is 3, and this is -4. 1 plus 3 minus 4 equals 0. So all we need just make x equal to 1, right? So the answer is x is 1. That's it.
I have also.
Huh?
Something.
Okay, Raga?
Yep.
Yeah, Leo, you have another thought?
Yeah.
Okay.
Instead of making the whole entire thing x, I made 2 plus the cubic root of 2 plus square root of 5 equal to a.
Okay.
And the cubic root of 2 minus square root of 5 b.
Okay.
And then I saw that the cube root of the cube of a plus the cube of b equals 4.
Okay.
And I saw ab is the same as the cubic root of a cubed b6.
Is what? The cubic root of what? A cube b6?
Yeah. So I saw.
Why?
Well, no, I mean a cube b cube.
A cube b cube, okay.
And I got that it equaled -1.
Equal -1, okay.
So after that, I kind of like saw that a plus b cubed was equal to a cubed plus 3a squared b plus 3ab squared plus b cubed.
Okay.
I already know that a cubed plus b cubed is 4. So yeah, I did that.
Okay.
And then after that, I saw 3a squared b equals plus 3ab squared equals 3ab times a plus b, which is -3 times a plus b.
Okay.
So
up to here is the same, right? So from now on, it's just you guess what is a plus b, right?
yeah.
Okay, so just a different representation. It's pretty much similar to what Raghav was presenting, but Leo's approach is just to separate, represent the two difficult terms by a and b, and then do the cubes, cube both sides. Okay, cool. All right, let's invite our spotlight student in here to talk about the last problem. Okay. Last problem is a geometry problem. Okay. So A, B, C, D, E, F is the regular hexagon, and we have G, H, I, J, K, L on the midpoint. And I gave you a few areas and then let you calculate the other area. So let me draw the picture first. We have the one I'm drawing may or may not be a real regular hexagon, but I tried A, B, C, D, E, F, and we have G, H, I, J, K, L, and there's M in the mid, not in the middle, but inside, and then it's saying, what, AGML is 41, and DJMI is 53. And then the other one is EKMJ. EKMJ is 67. And I'm asking what's the area of BHMG? BHMG. I'm asking for this area. Okay, Nia, go ahead.
Okay, so on the question, it said that it's a regular hexagon. So I know that ALMHBA. Wait.
AM, what? A?
I first separated each into half.
Okay. So you're connecting AM, BM, like this?
Yes.
Okay. All right. Okay, keep going.
Okay, and then I found AGM and GBM they're both A. So I got each of both sides A.
Like this?
Then yeah. The next two are B.
Next one is B, okay?
And then B, C, C.
B, C, D, D, like this?
E,
E,
F, F.
F, F, okay.
Then I saw that since it's a regular hexagon, then the A plus, then the C plus the F, those two should be equal.
Oh, because it's a regular hexagon, you're saying what? C plus F is equal, huh?
C plus F should be equal to A plus D, which should be equal to
C plus F equal to A plus what?
D.
D. Explain why. So you're saying C plus F, this is C, this is F. It's the same as A plus D. Why is that?
They're on opposite sides. So
Okay.
you can draw the line, and then they're on opposite sides, and then if it's a regular hexagon, then the length, they have one length that's the same. So
basically this is the base of this little triangle. This is the base. These two bases are the same. Okay.
Yeah.
These bases are the same. These four, the four highlighted lines, they're the same. Okay, keep going.
So the bases are the same. And if you have the whole length, that's the whole one whole length of the hexagon. And then since it's a regular hexagon, they're all going to be the same.
Okay, so if you calculate, basically, if you calculate the area of this C, there will be the base times height, right? Times height. I will do a height here, times height, divided by 2, right? And this F will be base times height, divided by 2, right? So this height, if you add up these two height together, this is the distance from one side from AI to CD, right? And that distance is the same as the sum of these two heights, right? So that's why C plus F equals A plus D.
Yeah.
Okay, keep going.
B plus E is also equal to A plus D in these two, because B plus E is also the same.
B plus E, well, they're all equal. So they're equal to A plus D equal to B plus E. Okay, go ahead.
Okay. And then A plus F is equal to 41.
A plus F is 41. Okay.
C plus D is 53.
C plus D is 53.
D plus E is 67.
D plus E is 67. Okay.
And then ACFD. ACFD together is A plus C plus F plus D is equal to 94 because I just joined the two equations together.
Okay, so you add up these two equations. A plus C plus D plus F is 94, okay?
Okay. And then A plus D is equal to C plus F, which is equal to, so since A plus D is equal to C plus F, then that means if you divide it by 2, then A plus D is also equal to 47.
47, okay.
And then B plus E is also equal to 47 because all of the are equal.
B plus, which one is also 47?
B plus E.
B plus E. Where is B plus E?
A plus D is 47, so C plus F and B plus E, they're both 47.
Okay.
And then A plus D plus B plus E is equal to 94.
Sorry, can't hear you clearly. So let's, so here, did I write it correct? A plus D is 47, right? A plus D.
Yes.
A plus D is 47.
And then A plus B plus D plus E, so all four of these together, is equal to 94.
94, okay.
And then since D plus E equals 67,
okay, D plus E is 67, so A plus B is 27.
Yeah.
All right, good. That's correct. All right.
There's an easier way.
Okay, hold on. Is there another solution? Good job, by the way, Ningye. Another solution? Is there another solution?
Yes.
Kyle, you already said one, so let's see if there are other students who can offer another solution. And we are almost done, so we have probably 5 minutes left. Any other student? Okay, go ahead, Kyle. You have to be very fast. Okay.
Okay, so because it's a regular hexagon, you can calculate that the h of this is equal to 2 times square root of 3x, and x is ag or gb.
Okay, x is ag or gb. So what's square root of x again?
No, 2 times square root of 3 times x.
2 times square root of what?
2 times square root of 3 times x.
Like this?
No, it's not inside.
2 square root x, like this, right? So x is the side, is the length of each side. Okay.
Well, actually, well, that's just showing that the height is always the same.
Okay.
And then I said AG and GB equal to X.
Oh, AGX is half of it, so this is X.
I mean, like, no, I'm not using the X anymore. That X anymore. I mean,
yeah,
like,
we don't have enough time for this, Kyle. Sorry. So let me quickly talk about another solution. Then we have to call it the end of the day because there's a time limit, unfortunately. Okay. So let me quickly talk about this. Sorry, Kyle. So unfortunately, we don't have enough time here. One way to do this, if you connect all these midpoints, okay, then you will find you come up with another regular hexagon. Okay, this is another regular hexagon, and all these triangles, they have the same size. Okay, and then since this problem is giving you the sizes of this hexagon and this one, and which other one, and this one, okay, it's asking you for this one, right? So if you for each of these quadrilateral, if you get rid of this little triangle, then the remaining triangles. So here's one triangle, another triangle, another triangle, another triangle. They have some relationship. The area of this triangle plus this one equal to this triangle plus this triangle. Okay. So in a regular hexagon, this area plus this area equals to this area plus this area. Okay. And this is what? This is 41. 41. This is what? 53. And by the way, it's not the triangle is 41. The triangle, this triangle plus the side triangle is 41. This is 53. This is 67, right? So that means 41 plus 53 equals 67 plus something. The last one, x. X equals 94 minus 67 is 27. Okay, so that will be my solution. Again, sorry, Kyle, we didn't have enough time for another solution, but I think this is the end of the day. We are running out of the time. Okay. Bye, guys.